All right, class, here we go. We have our calculator here, and it is in Moodle Mobile. And so I'm going to go ahead and upload this to copy to Excel. Okay. And I'm going to say duplicate. And of course, I want to put this into my resistance. And I think I called it Ohm's Law. So it should probably be called resistance calculator. And mine happens to be version 3. So you'll see I have another calculator in there, but I'm not going to use that. So this is what we're going to do. We're going to actually go and find the currents for a resistor that has, and I'm just going to put in resistor number 1, and that's 1 kilo ohm, and find the resistances going through that. And we're going to get our simulated resistance from that particular scenario by looking at a graph here. And it should have an equation of a line on here. If we don't have one, we'll just put one. Or I'll put one there for you guys. So let's go back to number 1. And let's go to our calculator here. And I say our calculator, but it's really a simulation program, but it's really a calculator. I mean, come on, it's a calculator. Okay, so I'm just going to select on this particular meter here. I want to get rid of that. And I want to select on this resistor. So before I do that, let's look at this real quick. You'll see that we can have an AC source, a DC source. If you remember, that was part of the symbolic representation that I was utilizing when describing the theory. So it helps to connect the theory directly, or the symbolic relationship directly, to the simulation. So we have a DC source. We're going to have to use a ground. We have square wave sources, dependent sources, DC rail. Okay, I don't know what all these things mean, but I do know about this resistor here. Okay, so we're going to talk about this. We're going to use this resistor, this DC source, and this ground. Let's go ahead and pull ourselves up a battery. And this battery, I'm just going to double tap on it. It's going to be our voltage source. I'm going to give it a voltage of 2, and I'm going to give this a label voltage source. And then I want to rotate it. Let me see, I think I can just rotate it by grabbing it. I just grabbed one of these handles and then I rotated it around. The next thing that I'll do is bring up a ground. So even though I didn't use a ground, that's just where things are going to be 0. So when I say 0, that's where voltage is going to be 0. It's really where all of the electrons that are really kind of close together and like some wire, they spread very far apart. Okay. So let's bring this up, and it's already at 1 kilo ohm. And I guess I could call it resistor 1. Say done. And then I just want to rotate this around and then move it. And all I'm doing is, if I want to rotate or extend it, I grab one handle. If I want to move it around, I'm selecting in the center. Okay. So now we want to connect all of these things together. And all I have to do is, let me see, I think I can just grab one unselected device and then drag it down to another. And I'll do the same thing on the other side. Drag this down to this, and then I'll just put my ground right here. It's not absolutely necessary in this simulation program for grounds, but you will need them in the future. So what we want to do is, we can look at the current going through this leg if we want to, and you'll see that the current is 2 milliamps. And we can look at the current going through this leg. It's still 2 milliamps, and this leg, it's still 2 milliamps. They're saying that it's negative, but it's still 2 milliamps. So what am I saying to you here? I am saying that this goes along with our theory that the current in all of this is pretty much the same, at least the magnitude of the current. So we want to type 2 milliamps into our calculator at 2 volts. And let me just go here. So 2 milliamps, that's 2 divided by 1,000. and you'll see that you get 0.002. That's 2 milliamps. Now we're going to do 4, 6, 8, and 10. So let's go here. We're just going to double tap on our voltage, and this is going to be 4. So we get 4 milliamps. Probably should have closed it out. 4 divided by 1,000. Okay, and then we're going to do this next one here. And I don't want to just make an assumption. I want to go ahead and make sure I put my values in. When I have 6, we get 6 milliamps. And remember that I've selected on this meter here, just in case you don't realize that. So this is 6 milliamps, 6 divided by 1,000. And next one is 8. So I'm going to double tap on this and say 8. Okay. Oh, I actually want to keep my meter on. All right, so that's 8 milliamps. Then we're going to do 10. Can you guess what that's going to be? Probably can pick up the pattern right away. I wouldn't use it as standard practice, but 10 milliamps. So let's go ahead and put this in. I'm just going to say equals to 10 divided by 1,000.